Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Annie Talvasto, and I'm a CNCF ambassador, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. They will build things, they will break things, and they will answer all of your questions. So, you can join us every Wednesday to watch live. So this week we have Salman here with us to talk about operating high traffic websites on Kubernetes. And if you are seeing a different title right now, that's due to some technical difficulties. Don't mind that. Today we're going to be talking about, as I said, operating high traffic websites on Kubernetes. Very excited for this topic. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that code of conduct. So basically, please be respectful of all of your fellow participants as well as presenters. So with that done, I'll hand it over to Salman to kick off today's presentation.
Hey, good morning, good afternoon, good evening, everybody. My name is Salman Iqbal. Thank you very much for the introduction there. I am Salman Iqbal. I work for a company called Appia. We are a cloud native consultancy, and we work in the cloud native ecosystem. So today, I'm going to talk to you about how do we scale our websites, which are running in Kubernetes. It's not only restricted to websites; it's just to do with all workloads that you're running in Kubernetes. I know when we talk about Kubernetes, there's a lot of talk around auto-scaling, so things that can automatically scale based on some traffic that's coming in, perhaps a metric or whatever it might be. But that doesn't happen by default. There's a lot of work we have to do. There's a lot of configuration we have to put into our system. And what are those things? How we can do it? That's all we're going to look at today. So it's going to be all demo, and hopefully everything will work. And if it doesn't work, don't worry. I have a video as well of the whole demo. We can go through it, and we can pretend that it was all live. But I've tested it a few times before as well, so I think it should be all good. If you have any questions at any time, feel free to ask, and we can answer as we go along. If I know the answer, I'll try and answer it. If I don't, then we can search up the answer the normal way, which is using Google. Or if you're feeling adventurous, we can ask the question in Chat GPT 4. How about that, Annie? You can decide if we can search ourselves what we should do. But it should be a good laugh. I think it would.
Yeah.
Whatever you prefer, we will do. Excellent. So what you're seeing in front of you is my screen. Whatever I'm going to be doing, I'm going to be sharing together. So here's this scenario. Scenario is you're running a website, and that website could be anything. Your blog could be an e-commerce website, could be whatever it is, and a lot of requests. Actually, I'll probably put some diagrams up in a second. If you give me a second, I shall open this diagram here so we can all see it together. 1 second. Let's just double check here. This is where we are. 1 minute. Okay, perfect. Let's get this open. What we have here is, give me 1 second. Here you go. So I hope you can see this. I know we all know all the various components, how things work in Kubernetes, but just a bit of a recap for all of us, what we're going to be focusing on today. Imagine this is our current setup of our website that's running. So at the bottom, you can see we've got some pods. Let's say the red ones are the pods which are serving the traffic. It's your website that's running. And then what we have is some services which are sitting in between, in the middle at the bottom there, in the gray bar. That's a service. Service is basically just a thing that sits on top of the pods. It is an interface, and that deals. I think of it as an internal load balancer. If you have multiple replicas of your pods running in a deployment, you can use that service, and the service acts as an internal load balancer to route traffic to one or the other pods, right? So something needs to do that. That's where the service sits. Service is all internal. We don't expose anything outside the cluster. Usually using a service, we for that what we use is an ingress. And an ingress is what I would call an external load balancer. And the purpose of the ingress is to take requests coming from outside of the cluster and send it over to the container that's running our website. And that's the purpose of the ingress. And the good thing about the ingress is it understands HTTP requests. So if somebody says, hey, I want to send a request to www.cncf.com forward slash, I don't know, checkout, it will send them, it can understand the request, it can look at the headers and it can understand the request and make the routing based on that. So we'll look at the ingress, we'll look at the service because we'll create this, and we'll look at the pod. Now, the thing about the ingress, which we're going to focus on today, the thing about the ingress itself is here you go. Next diagram here. They're not supposed to be the slides, but I thought we'll just have some photos of what we're going to see. The thing about the ingress is ingress usually comes in two parts. There is the ingress pod, as you see in here. The ingress is basically a normal deployment. So you would have you can pick any ingress controller you like. In this case, we're gonna look at Nginx. Everything we talk about today is open source, and we also have a link where you can try all of this yourself. So all the projects in are open source. So an Nginx Ingress Pod we're talking about is the open source Nginx Ingress Pod. And the point of this is, the point of this is that when it runs in the cluster, we install the Ingress controller. The cluster doesn't usually come with it, and it's attached with a service. So this is now is running in the cluster. So anytime request comes in from outside of the cluster, it goes to this pod, and that's fine. The problem is, what if you get millions of requests? This can become a bottleneck. Would you agree with that, Annie? I hope you would, right? This could
Yes.
become a bottleneck, right?
Great.
Because all the requests are going to this one pod. So if that happens, there's two things you can do. Number one, you can always have many ingress pods running. The questions that are coming in, I'll answer in a few minutes. So keep them coming.
Yeah.
Please do. It will answer in a few seconds. So the point is, what you can do is you can start off with a number of pods. You can say, you know what, instead of running one ingress pod in my cluster, because it's a normal deployment, I'm going to run 5 or 10 or 15. And that's absolutely fine. You can do that, but it will take up resources. So you'll have to allocate these resources, and these pods might not be doing anything for the time where there's not much traffic coming in. So it's a bit of a waste, and we don't like waste. So what we should do is scale up when there's lots of requests coming in, and scale back down when there are no requests. And that's what we want to do. So that's what we're going to look at today. How we can do this, how we can look at all of this, um, and then we can scale up. So before we go any further, there's a couple of questions in here, and I'm gonna can we go through that? Annie, is that okay with you? Should we go through some
Yeah,
questions?
that's perfect. We should go through them. Yeah, and I think the first one that came in is, can you route traffic other than HTTP or HTTPS using ingress, for example, PSQL request?
So yeah, thanks, Shadi, for that question. I usually you route HTTP HTTPS traffic using Ingress. I'm not sure if you can do PSQL, but we can check that later on in the stream. We can do a quick search ourselves together. Usually we deal with HTTP and HTTPS. There might be some extra controllers because these are different Ingress controllers. Some controllers might be able to actually. You know what we can do? I'll share some reference with you, which might be handy. So I work with Appia, and I also work with a company called LearnCates. Shout out to Daniel Deplanche from LearnCates. There's different kinds of Ingress controllers, and different controllers provide different capabilities. So you can see in here, this is a comparison sheet. All of this is open source. You can check out. You can contribute yourself as well, so you can Just search for LearnKate's research, and this will come up. And in here, there's Nginx Ingress. And then on the left, you can see different types of routing mechanisms. So maybe some of them might support it. You can check it out. But I'm not sure. It doesn't look like we can. So maybe different kinds of Ingress controllers could or could not support it. I hope I've kind of answered that question, though not. So
Hopefully. And if Shadi, if you want to ask any more or you have extra
yeah.
questions, feel free to pop them in there. And then we had another one from Laurentinas that they are curious and how should they define high traffic?
Oh, very good question. So that question is, how do you define high traffic website? How do we know something is high traffic? That all depends um, on your application itself. For example, you can say, look, high traffic is if I get, I don't know, 100,000 requests per minute. That's high traffic. That's all depends on what your setup is and what your setup can deal with, how many requests it can deal with at a time. For example, today, what we're gonna say, if we have, I'll share the metrics in a second. If you have 100 active connections inside each Nginx pod, and you can test this out yourself and trial it. You can see how much memory and CPU it consumes, and we know like 100 requests per second. This is just an example. 100 requests per second is quite a lot. So then we can scale up. So entirely dependent on your setup and your application. What is a high traffic website? You can pick a different metric, and then we're going to touch upon that later on today.
Perfect. And I think Shadi
Okay.
continued with, I suppose, yes, I have configured Ingress controller once to route
hmm
other ports than 804042 I used it to port 3100 UPD there.
Okay. Cool. So I think looks like should be good. So excellent. All right. Sounds good to me. Shall we carry on then, Annie?
Yeah, there was a comment in the beginning which was it is like AL7 load balancer, but there's not a question there. But obviously, if you want to say
Yeah.
something
Yeah.
to that,
That's correct. Yeah. I think that's what they're saying is absolutely right. So that's a layer 7 load balancer. That's what it's doing. It doesn't understand. So services do like layer 4 stuff, and then Ingress does the layer 7. So that's what they're saying is absolutely correct.
perfect. And then there was a
All right.
ask from Dennis to share the materials. I don't
Okay.
think we showed a Google Doc here before, but if there's any materials, we'll get them linked to everyone attending, as well as maybe you can share some learn more resources in the end and so forth. But yeah,
I will definitely will. That's great.
perfect.
All right, excellent. So here's the thing. Now, what we want to do, I hope you all understand. What we are going to do is in this demo, what you'll see is we'll deploy an application, and like a normal application, as you see in here, and then we're going to throw a lot of traffic to it. And what we want to do is we want to scale up this pod. So that's how we're going to do it. There's a few steps for it, which we're going to talk about as we go along. But first thing first, what we should do is deploy our pods, right? So let's deploy an application that we're going to deploy to the cluster, and then we can see what we can do in terms of scaling. Here we go. So let's just make sure it's all nice and big and everybody can see it. If you can't, please let me know. If you want me to change the background from dark to white, like we can do that too. But here's what we're going to do. Initially, what I need first is a Kubernetes cluster. Luckily for me and for all of us, what we're going to do is you can use any cluster you like. In this case, we are going to use Minikube cluster. Before, nothing is running on the cluster right now, so let me just make sure we have enough space. So what we have is kubectl get nodes. This is Minikube, right? So this is a local cluster that's running on my machine, and it's got nothing running inside. Well, just the components to run Kubernetes. That's all it is. We have nothing in there. So I'm going to go inside in here, cd demo, just make sure we're all in the right place. Yeah, excellent. So that's where we are. Okay, cool. So first things first is we need to deploy an application, deploy a website. Let's just pretend this is our website. This is our super fancy website that's going to get lots of traffic. And let's start with here. Let me just stick this thing here. I'm sure you've seen deploying files, plenty in your life. And what we have is we're using Stefan Prodan. Shout out to Stefan Prodan, pod info. This is, I'm sure you might have seen this. Basically, it's just a website. It's going to run. It's a static website. We'll deploy this on our cluster. It is a deployment. So deployment we can use to scale replicas if you want. But in our case, we're only going to run one deployment. And that's what we're going to do. So we'll take this, we'll deploy it. And we got some other information in here around like pods, which are running, labels. But the point is we're going to create this deployment first. Let's go. So let's go kubectl apply -f. We'll create the deployment. Hopefully, if everything's all good, we can do kubectl get pods and containers creating. There's going to be a lot of that during the demo. Of course, we'll just make sure the containers come up. It's taking a lot longer than I expected. Luckily, it's all come up. Okay, so the pod is not running. But how do I, just a tip to share with you all, how do I know if anything's running correctly? Usually what I do is if something is running and I want to make sure pod is running, and because I'm going to be deploying a number of components, I'll deploy a service, I'll deploy an ingress, and then we'll try and access it. But instead of just jumping through everything, I can test everything out, right? Let's just make sure. I go to kubectl port forward, because this is my local. I have access to the cluster. I can port forward it. I can say which resource I want to port forward, which is a pod. So this is the pod. I stick this in here. And then what I have to do is, this is the port the container is running on. That's the port the container is running on. So the syntax goes, I pick any port on my machine, 8888, let's say that. And then the port the container is running on, 9898 in this case. Let's just deploy that. So 9898. Now this is forwarding. So if I send a request from my laptop onto the here you go. If I go to localhost 8888, this is the website that's running inside the pod, right? So the first step is all good. We have a pod that's running. It's giving us a website. This is the website that people really want to visit because they want to see this cute little creature on here, and that's what they want to visit, right? And what we're going to do next is we need to make this available outside of the cluster, so you can send requests to it. Well, for that, as we talked about before, I need to create a service, and then I need to create an ingress, so people can send requests from outside of the cluster. So let's just go ahead. Nothing too extensive at the moment. What we have is another YAML file. There's going to be quite a few of those today, as is always the case. I'm sure you agree, Annie. Lots of YAML files. We will create a service, and a service, as we said, is an internal load balancer. And in here, there's a few things. We need to make sure that some of the configurations match up, and that's what we're doing in here, and picking the right pod. So this is the deployment that we created, has these labels: app info, pod info. And then what we have is this bit here, which is the target port. So when I deploy the service will be attached to this pod. So let's go ahead and create that service. So if we do this, I'm going to close this a second. So we can stop this. We don't need this anymore. So I'm gonna apply myself deployment. Oh no, we've done the deployment. Service.yaml, right? So that's what we are doing. Now the service should have been created. kubectl get service. I can do that. Just make sure everything's correct. Now this is the service type load balancer. And if there's different types of services in Kubernetes, there's cluster IP, there's load balancer, there's node port, and there's one more, which I can't think of right now. And then headless, which is the smaller service. Yeah, that's right. This is using a load balancer type service. This is running locally. If this was running inside a cloud provider, it will actually go in the cloud provider. It will go and provision an actual load balancer and attach it to the nodes which are running these workloads. And that you can imagine if you create like multiple services with multiple load balancer types, and you end up with so many load balancers, it could become quite expensive. You could have a lot of load balancers. And this is why in order to expose services outside your applications outside, we use an ingress. But we need the service because we could have multiple replicas running. Now I've deployed this. In order to check everything is correct, I can do the same thing as before. Port forward.
Yep, and there was actually a question from the
Yep,
audience. Oliver was a fan of the comparison table of Ingress controllers.
yep,
Is it available publicly? And they would
yep.
like to get the URL.
Sure. Let's just do that right now because I'm just looking at the other screen. Here you go. I shall stick this. I can stick this in the chat, right? So if I stick
Yeah,
this in the chat, Annie, you can. We can share it. So that's the Ingress, and there's actually quite a few other things in here you can check. Like there's Ingress controller comparisons, managed Kubernetes comparisons. There's comparisons on service meshes, and yes, it's all open source as well. Of course, please feel free to add, send pull requests. All the information is on that page. Okay, excellent. All good. Right, so this is the service that's running. I just want to make sure the service is configured correctly. So I can do the same as what we did before. We can do 9,000 and then uh, we can test it out. So let's just quickly do that. Localhost 9,000. And as long as we see the same page, that means what we've done is we have done everything correctly. So the service is configured correctly. And so far, we're looking good, right? So we've done that. But what we really want to do is install an ingress. And what I'm going to deploy a few components first, and then we'll break and take questions in a few minutes. If that's all good, and we'll just deploy all the components. Then we'll take some of the questions in a second. So here's the thing, though. What I want to do is I want to deploy this ingress, and the ingress is something like this, right? So I'm going to show you some rules in an ingress. Let's just go back to here. So you saw the service file, and I'm going to show you the ingress file now. And the ingress file looks something like this. We have the kind of resource that we're doing, some metadata, but this is the important bit in here, the rules of what we are going to send down. And here is what these rules are. These are all the HTTP rules. And the rules are like this. All it says is if somebody sends a request to this path, so just the base path, you can put anything you like here, blah blah. You get anything you like. You can put anything you like in here, and if you send a request, in this case we're saying to the base path, send that request to the service pod info, the one that we just deployed. That's where we want to send it to. Now, the thing is also, well, the request should be coming, for example.com. So if somebody sends a request, this is what we are actually asking. So this is not just path-based routing, this is host-based routing. So if the request is, for example, .com, then what we can do is basically we can send this the request to the pod, to the actual service, and then down to the pod. But here's the thing: if I apply this to the cluster, so I can apply this to the cluster right now. So let's just stop this. We don't need this. We're gonna do k is the alias that I use on my machine for kubectl. K apply -f ingress.yaml. Deploy this on the cluster, and it just goes in and it stores the information inside the etcd database, but it doesn't know what to do with it because there's nothing inside the cluster that tells it what to do with it. There's no controller that's running inside. We haven't installed anything. We haven't installed this bit yet. This ingress pod is not running yet. So how do we do that? Well, we can install this on the cluster we can go to their website, and there's a number of ways of installing it. What we're going to do is we're going to install using Helm. And Helm is a package manager, as you might already be aware of. And the good thing about Helm is you can have what's known as Helm charts. And the charts allow us to install all the components necessary. And that's what we're going to do. So let's just quickly install this. So I'm going to do Helm. I have the command in here. I'm going to copy it from my other screen because I have it there. So this is just adding the repository, which I already have. And then I can just use the Helm install command. Let's just stick in here. I use the Helm install command. And from that repository, I can install the Nginx ingress on my cluster. So it will install a bunch of things in my cluster, the controller that it needs to run inside a pod, and also services and anything else that it might need to install. And you can set some variables at the same time. I'm just telling it to also use basically watch ingresses without class. You can define a class that ingress uses, but I'm just setting that right now. So once I run that, what it should do is basically go ahead, get all the bits that it needs, bring all the yeah, here you go. Bring all the configuration down and apply it on the cluster. What I'm doing right now, just for demo purposes, I'm installing everything in the same namespace. That's where it's going. Everything is going in the same namespace, which is the default namespace, just for demo purposes. Usually, you would deploy things in different namespaces, and that is the right way of going about it. But this is just for demo purposes. If I do kubectl get pods, what I should see is this bit here. What we've installed is nginx, so pod info, and this is an nginx ingress that's running. So this is the controller that we've deployed, right? So far, we're all good. We've deployed the ingress, and then here's what we're going to do. Because this is Minikube, this is running locally, right? And the name of this ingress is nginx. I can see if I can try and get to the pod that I have deployed. And in order to do that, I can do a number of things. I can get the because this is local. This is local, right? So I can get the IP of the Minikube, and that will just that will basically be able to access that. I'll answer some of the questions. I see some good questions that are coming up. I will answer that in a second. I'm just going to quickly show you the website that we can access, because our thing was, if somebody sends a request to example.com, now this is running locally, send it to the pod. But I can use a new command from, so we have kubectl get service. As I said, ingress is normal a service, which is in here. You can see this service here, load balancer service is called main nginx ingress, right? So you know how we did port forwarding? This is what I can do. Minikube service, similar to that, main nginx dash ingress and dash URL. This will just give me a URL locally I can use to access the website, just to make sure what we're doing is absolutely correct, right? So it's going to run. There's a spelling mistake in here, and they should run in a second and give us the URL. Here you go. It's given us two URLs in here, so I can access this and see if the website is there. But the problem is I can't do that because I have this host property inside. So what I can do is I can curl actually. Let's just make sure this command is running. As long as this command is running, I can curl it. I can do this. I can pass in a header. And we're building up to the part of scaling in a second. Example.com. And then I can stick the URL that's been given to me. And you can't, I know this is not as exciting as seeing the cute little creature that we have in the URL, which let me see if I can hop back onto. It's not as exciting as this, but what we can see is well, there you go. That's the message greeting from pod info. This is where the logo is coming from. I hope you all agree this is what we're doing. So far what we've done is deploy our application. And the bit that we're going to do next is what we need to do, and we'll take a couple of minutes to answer some questions real quick, and then we'll move on to the next part. We've got this setup complete. We've deployed our application. We deployed Ingress. We know Ingress works. We've sent the request to it, and we can see it running. But there was only one request. What we're going to do in a few minutes is we're actually going to do a lot of requests and see how we can scale up. But for that, I need to do a few things. I need to decide how do I scale up. So I need to pick a metric that can scale up. And then I need something else to help me to scale up. And then I think, Annie, this is maybe a good point to answer some questions. There's one question I think I'll start with, if that's okay, because that's
Yep.
that we can answer really quickly. I think there's a question on, can I add multiple ingresses? If possible, are there any precautions when using it? Yes, you can add multiple ingresses in the cluster. What you have to do is in here, you can have multiple ingresses, and let's just go in here. And then what you have to do is in here, you have to define what class name you're using. What do you have to watch out for? Well, the things that you have to watch out for, just make sure you use the right ingress class name for the ingress to use. I've seen some examples in the past where people have run multiple ingresses in the same cluster because of different requirements from different kinds of applications. But yeah, there's not everything that you have to watch out for when you set up an ingress is the same. What you have to do, for example, don't declare the same host twice, but I don't think there's that many pitfalls for it. I wanted to answer that because it's related. Any what other questions we got so we can quickly answer?
Yeah, of course. And I also appreciated that Mikhail provided a link to Kubernetes docs for Xing to check out as well. That's always great to see. And also,
Thank
there
you
was a
very much.
question before to get the link to the previous resource to LinkedIn as well. And Jillian helped out with that one, so thank you so much there as
Excellent. Thank you,
well.
Julian.
Yeah, and then we have the questions. So there was a question which goes as, how does Kubernetes know that I'm running my Kubernetes in a cloud provider such as AWS, and how does it know what type of load balancer to provision? And there was some helpful information already provided by another commenter, but
Yep.
obviously let's answer the question here as well.
Yeah. So yeah, I think Avinash also on there answered the question. So when you deploy inside Kubernetes in a different cloud provider, what happens in Kubernetes is when you create resources, what you can do, you have something called controllers that's running inside the cluster. So built-in controllers like the replication controller. So if you create a deployment, the replication controller is watching in etcd to see if there's any changes for it, and it creates that. The same thing happens when you're doing a cloud provider. They've got their own controllers, which is extra bit of logics that's running inside the cluster. So when you deploy something, it basically acts upon it. It says, "Yo, I need to create a load balancer," and it will tell you already. You already know if you want to create this kind of load balancer. This is the configuration you have to pass in order to create this. You can see in here in well, there's spec in here, but there's metadata information. There's annotation section also, which we haven't included in here. In the annotation section, you might have to give it some helpful hints as if you need something additional. So each cloud provider will ask you to do something slightly different in the Ingress configuration. So the Ingress is the only part which could be slightly specific to different managed provider, but everything else stays the same. In here, you'll have annotation section. You might have to add some extra bit. Hopefully, that answers it.
Yeah, perfect. And then the last question so far comes from Alejandro, who asks, is it necessary to deploy a service in load balancer mode if I'm using my
Mhm.
cluster within a public cloud? In this case, wouldn't it become enough to configure an ingress pointing to the service, and the load balancer would assign the external IP to the ingress instead of the service?
Oh yes, a very good question. Again, yeah, it's not. I just did it as just to show, but yeah, definitely not. It's not necessary to deploy service in a load balancer mode. We don't want to do that either because we're gonna have an ingress that will take care of everything. So you don't have to. You don't have to deploy in a load balancer mode. That's absolutely correct because you can't do any authentication. You can't do any of that stuff. So yeah, that's what we're gonna do.
Perfect.
Cool.
And we got a comment from one of the earlier questions askers that perfect makes sense. Thank you. So perfectly done there.
All right,
Um,
perfect. Yeah.
yeah. And then we have Parul asking that if this repo is public, can you please add the GitHub link as well?
Sure, I will do. I'll share the link in a few minutes when we take a break. But yeah, there's a whole blog that Daniele Planchett put together on this stuff. I'll share the link in a few minutes, and then we can you can check it there. Is that if that's all good? I have to dig it out. It's somewhere here, but you'll have to give me 2 minutes to do that. But we can continue on if that's all good.
Yeah, sounds good.
Th- Thank you, Annie, for keeping it ticking along. This is excellent stuff. Okay, cool. So what we've done so far is deployed our application, but here's the bit though. What we want to do is scale our ingress. I'm going to talk about ingress, but you can assume all of this also applies to anything, not just the ingress, but you can apply this to any kind of pod that's running inside your application. You can pick any pod you like, and you can do that. But we're going to talk about ingress, but just because it's a good use case. Before I can do that, how do I scale up? Is the question. The question is, and the way you scale up is you need what's this is what we want to do. I'm going to put this diagram up. Here you go. Imagine we have a deployment, which is our ingress deployment. It's running some multiple pods right now. Let's just say it's just running one. And then what we want to do is query some metric. Um, so query some metric. I think there's some questions. Service meshes will answer that later. So what we want to do is we want to query some metric But how do we get this metric? Well, there's a few things you have to do to get these metrics. Number one, your application has to provide these metrics. So usually, if it's a website, you would create an endpoint in your application / metric and add those metrics in there, whatever the metric might be. And I'll show you an example of that. And then the other thing is you need something to scrape this metric and store it. And for that, what we're going to do is use yet another open source project called Prometheus. Prometheus. This one. Prometheus monitoring. And that's what we're going to do. I don't know if people have seen this movie. I haven't, but apparently it's a very good movie. So what we're going to do is we are going to use another open source project called Prometheus. And the good thing about Prometheus is it comes in different parts. We can install it on the cluster. You have what's known as a Prometheus server, and that's basically the central component for everything. It scrapes the metrics and stores it, and in the right format, in the format that it needs. And also the good thing about Prometheus is it can talk to the right components. Well, when I say right components, I'm talking about the Kubernetes API and discover all the services that are running in the cluster and all the pods. So you can go ahead and find it. But the main thing is all the containers that are running in the cluster, if they're exposing metrics on an HTTP endpoint on usually / metrics path, it can take all those metrics regularly and store it. And that's what it does. And this is really good. And also it gives you a really cool dashboard, which we're going to use in a second. So basically what we need is somewhere where we can store these metrics. And then once we have this metric, then there's another component inside Kubernetes, another kind of resource called the horizontal pod autoscaler. There's two kinds of, well, really in Kubernetes, you have three kinds of autoscalers. You've got the cluster autoscaler. So if you want to scale up the cluster, depending on if you're running out of resources, you have what's known as a horizontal pod autoscaler, which is just increasing the number of replicas of the pods. And then there's something called the vertical autoscaler, which we're not going to touch upon today, which is just increasing the size of the pods, like allocating more memory and CPU and that sort of thing. But we're going to talk about horizontal pod autoscaler. So there's a component called the horizontal pod autoscaler. And then that's what we are going to do. So there's a bit that we're going to query, and we are going to use the horizontal pod autoscaler. So how do we store these metrics? How do I get this? Well, again, lovely Helm. We're going to use Helm, and we'll install this. So if I can, I think the screen is big enough. And then if I do Helm install, Helm install pro. Let's just do this. I have, for the sake of saving a couple of seconds here, we're just going to install Prometheus. Again, once we install Prometheus, we'll have a bunch of pods that will be spun up for us. So let's just make sure everything is good. Get pods. So you can see in here, as I said, it installs a number of components, right? There's a server, the bit that we really care about. We care about pretty much everything. There's a couple of bits in here which are doing different things. We have Alert Manager if you want to send alerts. If you haven't tried Prometheus, I would highly recommend trying it out. If you're looking for a solution, there's many solutions out there. Of course, check it out on landscape.cncf.io. A bunch of solutions for monitoring. But this is a really good one to get started with. As you can see, for me, it was quite simple to start with. I can install inside the cluster using Helm. And once it comes up, I'll just wait for it to come up. Everything's almost there. Server is almost there. So once the server comes up, what we're going to do is then we will going to start collect some metrics, right? But what metrics can we collect? Because here's what we want to do. We can decide ourselves what we're going to scale up. And what we are going to scale on for our thing is here's what we're going to do. I'll show you in a second. Luckily for us, I don't have to modify the Nginx deployment itself, because luckily for us, there's some metrics that it already exposes, and this is the Nginx's this page. It already exposes a number of metrics on the / metrics endpoint, and one of them is Nginx connections active. So if there's active connections in there, I can scale up. But we can define that ourselves. We can define our metric. We can say, hey, if there's like more than 100 active connections inside each deployment, scale up, because that's a lot for that to take in. That's what we're saying, right? So we don't have to do anything. But if this was your application, you'd have to go in and you have to make sure that you're exposing the right metrics, right? For example, let's just go in here. Let's just make sure we got our pods up and running. Luckily, so far we are good. So everything is running. Let's just check if I can do Minikube service Prometheus server, we will get that lovely UI on which we can go in and have a quick look, see if we can see some stuff that's running. So here you go. It's gonna start up in a second. Here you go. Here we are. So this is what it looks like. I can like query something. Let's just say if I want to see how many CPU cores I'm running, right? So let's just execute this. And machine CPU cores, it looks like there's a lot in here, but really, all of these are the labels to go with the request that we made. And you can see, oh, this machine has 8 cores, right? This is the value that it's giving. And also, we have a lovely graph in here. We can see this graph. It looks good, right? So we got the graph. But how about the bit that we actually care about? Well, the bit that we care about, the metric, is the Nginx. Ooh, let me see if I can type this correctly. Nginx connection is active. Hey, look at that magic! All I did was install Prometheus, and Prometheus managed to grab the metric. It understands it already because the metric is already exposed. It picked it up. So let's just execute this. And let's just go to the table real quick. One, we sent one request. Remember that? Like we have this pod info open that we send the request to. So basically, there's just only one active connection that's running. Oh, that's kind of cool. But we'll pump a lot on there. I'll answer some questions in a minute. We'll just go through this, and you can see there's only one Nginx connection active. Now, how are we actually gonna do? How are we going to pump a lot of requests in? And for that, what we're going to do is use Locust. And Locust is another open source tool that you can use written in Python for load testing. And it's really great. You basically have the Locust file. I'm just gonna, if you haven't checked it out, definitely check it out. If you're looking for something to do with Locust, I'm just gonna briefly show you. There's just an example in here. If you've written Python before, might seem familiar. If you haven't, it is kind of straightforward. In this case, we can define a locust file.py. In there, we can write all the configuration. Hey, go to this URL, go to that URL. This is how many users I want to have. This is how many concurrent users I want to have. You can write this. And the good thing is we can do this in Kubernetes as well. How can we do this in Kubernetes? Well, I'm glad you asked. This is how we can do this in Kubernetes. We can write this configuration. First, we can deploy more YAML file, Locust itself, because it's basically a Python package, right? So that's the Python package you can install using Python. We can run Locust. That's good. Locust will run on our cluster. But if you want to, and then we have a service, everything, because we need to have that UI to send that. And then the locust file.py that I was talking to you about, the one that where we write what we should be doing, is this bit here. Locust config map. Config map is something which we use in Kubernetes to store some information. And config map in here is what we're saying is just send the request to example.com. That's what we're saying. That's what send the request to example.com. And then we're going to ramp up, right? So let's just deploy Locust. It's making sense so far, Annie, I hope, right? So that's what we're going to do.
All good.
Excellent. So perfect. Prometheus will keep running. And let's just go to the right place where we're going. Make sure we're good. One sec. All right, yeah. So let's apply that. Ooh. kubectl. I just want to make sure we do the thing that we're here to do because we might be running out of time. Apply -f. Come on. So, okay, get pods. Now Locust is going to be up and running. That's just our load testing thing, right? So this is how do you do load testing, and this is how we're going to do load testing. But how do you actually do the scaling, right? The thing is, we have the horizontal pod autoscaler, and the horizontal pod autoscaler is very good. If you go to Kubernetes HPA, Kubernetes horizontal pod autoscaler, which you can check out yourself later on. The thing with the horizontal pod autoscaler is I can define in here, if we could scroll down for a sec to the right place, we can say stuff like, where are we? Am I in the right place? Yeah. We can say stuff like, hey, if the memory goes, if the CPU, if the application is consuming more than 50% of the CPU, scale up. or if it's using this much memory, scale up or scale back down. What it doesn't do is for you can do custom metrics, but it's a little bit more involved. There is a little bit easier way of doing all this stuff, and this is where something called CADA comes in. Yeah, another open source Kubernetes event-driven autoscaling. It doesn't just give you options of a few things like, oh, you can scale based on this. This basically feeds into the horizontal pod autoscaler. This is not autoscaling because the purpose of the horizontal pod autoscaler is to increase the number of replicas in the deployment. So what we can do, we can deploy this in the cluster, and this comes in multiple. It's got multiple parts too. I have a diagram to show. Let's go in here. Head up. And once you install in the cluster, what it has is a few things. It has a metrics API, so it can consume metrics. For us, we're using Prometheus, but it's all good. This can consume metric too. Instead of Prometheus, you can use this. And then it has the adapter to make sure to put the metrics in the right places. And then it has a controller, the bit that runs inside the cluster, that says, okay, this is what I need to do. Installs a bunch of custom resource definitions, which we're going to touch upon. And also, the thing that we're not going to cover today, but something that you should really check out is the scalers for CADA. For example, the good thing about is, if I can go to the scalers, you can have a bunch of scalers. For example, you have something like Kafka queue sitting outside the Kubernetes cluster where it might be sitting, and you might say, hey, I want to scale up if there's messages, more than 100 messages in a Kafka queue. And then you can scale up based on that, and you can define that. Or you might base it on a different, like a SQL query. With a SQL query, scale up on that. Well, that's what CADA is excellent. So definitely check out open source project CADA. Check it out. And installing it is the same as before. Really, what we're going to do is we are just going to install using how, and we'll answer some questions in a second. Just want to make sure we get to where we want to get to. So I'll install this inside the cluster, give it a second. I should bring up all the components that we need. Clear. Okay, get pods. So here you go. You can see this operator is starting up. That's the bit that's going to figure out when to scale up. But how does it know when to scale up? Well, this is where we use, let me just go here, something called the scaled object. This is not Kubernetes native, but once you install CADA, it installs these custom resource definitions. And in this case, what I'm telling it, hey, your target is this main Nginx ingress deployment, right? That's the one that we want to scale. We can give it some information around how many replicas we like to have, minimum, maximum. What's the cooldown period? After that, it can go back down. What's the polling interval? 1 minute or whatever it might be. But the main thing is, what is the trigger? And the trigger is type Prometheus. So we want to go to the Prometheus server, look for this metric name, Nginx active, and that's the metric name. But this is our query. What we're going to do is look for the Nginx ingress active connections that we talked about before, match it to that name over 1 minute, and the threshold is under 100. So if the requests for a pod go over 100 active connections, scale up, and it will decide how many replicas it needs to have, and that's what we need to do, right? So that's what we're going to do. So if I go in here, let's just make sure we got the right pods are all running, everything is good, and I can deploy this scaled object, apply -f, scaled object. So the scaled object is going to sit in the cluster, and let's just give it a second. Taking longer than hell. Ooh, there you go. Even if it takes a split second longer when you're doing a demo, feels like an eternity. But that's where we are. So what we got is everything is now set up. We have everything in our cluster. Let's just quickly scale up, because I know we're running out of time. So let's just scale up. But there's one more thing I'm going to do. What we want to see is, let's just go in here. I'm going to bring up the Locust. Let's bring up Locust. This is because it's deployed as a service as well, so it's going to bring up Locust in a second, and then we'll have a UI in which we can start sending information. So let's just put this on the side real quick. Let's just do that. How long we got, Annie? How are we doing for time?
We have 10 minutes left, but we already have 5 questions to answer already. So yeah.
Okay. Cool. So let's just quickly do this demo and then we'll answer the questions. 5 minutes for the demo, 5 minutes to answer questions to finish bang on time. Does that sound like a plan?
Absolute perfection.
Okay, excellent. So what we got is a couple of things in here. So we have this thing. We have Prometheus, which is running. So let me just quickly do this. Hey, how about this, right? Look at that. Nice. What we're going to do is start sending requests. When we start sending requests, and this is the UI, but what we want to do is see the pods scale up. We're not gonna just do like qctl get pods. That's a bit boring. So I'm gonna do something to give you a little bit more fancy. So let's just quickly go to the UI, the place that we are. Yeah. Scaling. This is also in the repository, and we've got this dashboard that Daniele put together. So I'm gonna run this dashboard, and you'll see that in a second. Let that spin up. Give it a second. Let it spin up. Localhost 8001. Oh, that's not great. How about that, right? We do not want we don't want to see this is basically pulling information from the cluster itself, all the pods that are running inside the cluster. That's all it's showing you. So these are all the CADA operator, blah blah. That all matches up. We have one Nginx pod. So once we start sending requests, what we should see is the number of requests increasing, and then eventually we should see the pod scaling up because we've defined everything. We've got metrics that we're collecting. We've got the scaled object. We have the pods that are running. And that's what we're going to do. So here's what we're going to do. We are going to send the request to the ingress directly via the host here, which is the service itself. And we'll do something like this. So let's have a peak users of 2,000. Why not? As you can see, I tested this out. Spawn 10 users per second. So we're going to start swarming in a sec. And then this is Locust. It will start giving you some information. Like you can see, it will start ramping up. What you can see is a total number of requests. I'll have to zoom out slightly so I can show you all the information. Total number of requests. Ooh, make it a little bit bigger. Total number of requests that are going in, and response times. It's taking a little bit long because what we want to do is, if I can execute this again, and we should see in a second a bunch of requests coming in. So let's just execute that. It'll take a second, and what we should see is a lot of requests coming in. There's a bit of a lag in here that you can see. And then what we should see, if I go in here, let's open this. kubectl get pods. What we should see is, oh, look, Ingress is already starting to spin up, right? We didn't do any of that. You saw I didn't do this because CADA came in and started to see, hey, you have a bunch of requests that are going up. So if the requests are going up, response times were going up too, but active connections were also going up. So let's just quickly execute this. Oh, you can see there's a faint line in here, but you can see that active connections have shot up real quick. And what we have now is, if I can hop back onto this, you can see three pods that have come up. This is I'm not making this up because this is all happening in the cluster. So if I do kubectl get pods, we have a bunch of these pods that have come up. And then more will come up as it requires. What CADA does is it actually calls horizontal pod autoscaler. So it creates that autoscaling for it. And then it updates the deployment, right? So it updates the deployment directly, and then it basically starts scaling up that it needs to. And this is what's happened. We've gone from 1 to 3. And if I let this run for a while, you can see like 3 are dealing with it, 100 requests per second. They're all dealing with this fine. Usually when I do this, if I were to do it, like I'll let it run, and then we can pop in the horizontal pod autoscaler. It'll scale up. And you don't just have to do it for this. You can do it for anything you like. How does that sound? Looks like the demo worked, right? So we look good. We scaled up. You can do this for anything. It doesn't just have to be for Ingress.
Great.
So I think we should start answering some questions. Oh, look, we got more pods. Yeah. What I'll do is, while we answer questions, I'm going to stop this. So by the time we're done, we'll see the scale back down. So we don't want to, put any more requests. All right, go for it, man.
Great, perfect, and great that the demo worked. There was always a bit of nerve wrack about that. So there's a question that came in, which is the first in line. Please explain how does all of this come together with service mesh like Istio, for example.
Uh, so service mesh is you can inject. So service mesh is used for a number of other things. This auto scaling is not part of service mesh. It's not one of the features of service mesh. It doesn't do that. But you can still have service mesh that's running. You'll just have to make sure you know like if you're using the right ingress gateway or the ingress itself. That's the configuration that you have to do, which is doesn't touch any of the auto scaling stuff. But yeah, the Istio service mesh do not have the auto scaling capabilities. For that, you have to use this. I hope that answers the question a little bit. But yeah, apart from that, everything else is the same. It's not much different.
Great. Then there was another question. I thought the default installation of Nginx Ingress controller using Helm will install Ingress controller as daemon set, thus one pod per node.
Yeah, this I think it's a deployment. I can't remember. You could be absolutely right. It will start one pod per node, but the thing is, I have one node, and here is Minikube, which is fine, and there'll be one pod, but it's not necessary that one pod will be able to deal with all the requests that's coming in. So it's just for the demo purposes. I installed using Nginx, but you can go with the daemon set. That might be enough to handle the traffic, but it might not be. So you might want to scale up more than the daemon set that might be running.
Yeah, sounds good. And then Jose asked, can we configure the time interval in which Kubernetes scales our application in the cluster based on usage metrics? Let's say, for example, we have some deployments that we need to react faster to an increase of incoming load than others.
So the question, if I understand this correctly, if we can scale up for specific deployments faster than others, is that correct? Did I get that right?
I guess it's a time interval that
Hmm.
they are
All
looking
right.
for. Yeah,
Okay. So the polling interval. Yes, you can change that polling interval. I can't remember what the least the lowest value that you can set. Yes, you can change that polling interval. You can go much faster. That's very well picked up there. And yeah, that's you
perfect.
can change that.
Yeah, and then Rama asked, can I use Kibana for visualization?
Oh yeah, you could use anything you like for visualization. Usually, for with Prometheus, Grafana goes well. I know they both rhyme, Kibana, Grafana, but Grafana goes quite well with visualization. I've never used Kibana with if I'm using Prometheus, but you can, yes, you can use that.
Great. And then Jules asked, is it possible to scale up across different cloud providers instead of relying on one?
Very good question. So the question is, can I use I'm going to assume the question was, can I use CADA to scale across multiple cloud providers? Is that correct? Do you think that's the question?
Yeah, I think it was maybe during CADA or just before CADA that the question was asked, but I think they're maybe looking for any solution that can help them with that.
Uh, I think it's a little bit. There is some stuff that was done. I'm just going to think about. Let me have a quick look, or we can quickly pop into Chat GPT and ask it. I think if you're doing it by cloud provider across multiple cloud providers, there is more work that you have to do. There's probably some projects out there that can help you with it. I can't really think of it at the top of my head, so honestly, no idea. Multi cloud stuff is always harder, but you might have to check some other projects to do that.
Yeah, multi-cloud is definitely a very big topic, so there
Yeah,
should be a lot of content around that.
yeah,
And then there was another question, one from Diego. If there's a DDoS attack that sends a lot of requests, how we could avoid autoscale to current the budget? WAF in front of the ingress is
yeah,
the solution.
yeah. Web application firewall. That's an excellent suggestion. Yeah, you can definitely use that to make sure that you protect yourself from DDoS, and there's a few more options there. So yeah, Diego, very good point. Yeah.
Right. And then we had Oliver asking, what is the URL of the Git repo that has this code? I think
Yes,
asking
I
us the
am.
same as the previous one, if we can share it or not.
Yeah, I am gonna find this in a second, and I'll share it. I'm just looking for it right now.
Yeah,
It's in
no
here
worries.
because yeah,
Yeah.
it's here.
There's two
Okay,
more
and
questions to go, but we are at the hour. But if we are super quick, we can maybe just, tackle
go
the
for it.
two as well. So what
Yeah.
is the difference between the autoscalers provided by CSP and CADA? Is CADA compatible with Traffic Ingress and OKA cluster?
CSP and CADA. I'm not aware of
Maybe they're
CSP, but
maybe it's
the
cloud
thing.
service provider.
Oh, the cloud service provider. Okay.
Yeah, my guess.
Yeah. So I think cloud. So I've seen that cloud service providers are integrating CADA in their solution, but I think all the cloud service providers also don't provide this by default. So this you have to add this on top of it. There's nothing the cloud service providers provide you to scale your application like that. I'm just sending the URL as well for
Yeah,
this. Here you go. That's
perfect.
the URL. There you go.
Uh, Good.
It's a bit.ly URL. Nice to find it.
Perfect. And then to the last question. Oh, there we go. It's sent. So
Awesome.
for people who are in YouTube, the link is bit.ly/KCD. And then is it
Dash scaling.
dash scaling? Yeah.
Actually, let me put it up in here. Here you
Yeah.
go. That's the link. You can like screenshot, do whatever you like. So here's the links: appia.io. Then we have a bunch of blogs on there. Check it out. Learncase.io. So all the resources are in here. The demo at the bottom is bit.ly/KCD scaling. So you can check that out on there.
Perfect. And then just a quick 30-second answer or so to question, do we need to scale up other cloud-based ingress controllers like AWS load balancer controller?
It all depends. All depends. If you can handle requests that are coming in, that's fine. Otherwise, if you have control over it, you should scale up. I mean, it's not ingresses are usually very good at handling the traffic. If you have the right number of instances running, sometimes you might have to boost up or not. But this is just one example. You should really look at: do you need to use this for your workloads too? But you can, depending on what's happening in your cluster, if your cloud provider controller can handle it. Usually they are good. Usually they are good. But
Perfect. And well answered there on quick as well, because we are out of time. So let's start wrapping up. So thank you everyone for joining the latest episode of Cloud Native Live. It was great to have a session about operating high traffic websites on Kubernetes. And as always, and particularly this time, also really love the introduction and questions from the audience. So many questions, great that we got to through them all. And as always, we bring you the latest cloud native code every Wednesday. So in the coming weeks, stay tuned for more great sessions. Thank you for joining us today and see you all next week.
thank you.